Hello everyone. In this video I am going to teach you about union operation, how to find union operation of array A and array B in C. Union operation means we have to write all the elements present in A and B in C. But one condition, it should not be repeated. It should be, you should write all the elements in A and B only once in C. Only once it should be present. That is the union operation. Now let's see, there are two types, unsorted and sorted arrays. Now first let's solve unsorted array. Let's see how this union operation works here. Now see. Now I is here. I is at this position. J is at this position. Now first thing, you should copy all the elements present in A to C. Now K is for traveling in this C. Now you should copy all the elements present in A in C. So I am writing 3, 5, 10, then 4, then 6. So I copied all the elements present in A in this C. Now next step is, now you should, J is at 0. Now this your B of J is 12. Now you should compare 12 with 3, whether they are equal or not. Now see, now they are not equal. So you can write 3 over here. No, you can write 12 over here. Sorry, 12 over here, B of J. Now you should, now J is at this position. J is at first index. Now you should compare whether 4 is present in this element, any elements of A. Yeah, 4 is present here. So you can't write 4 over here because it will be repeated. So now change J value to this. Now compare whether 7 is present over here. No, 7 doesn't present. So you can write here 7. Then J value increases here. Now you should compare whether 2 is present here. No. So you can write 2 over here. Now J is over this position at last index of B. Now you should compare whether 5 is present here. Yeah, 5 is present here. So you can't write. Now this is the result. This is the union operation. You have written all the elements of A and B in C only once. This is how this union operation works. Let's write the code how to write. Now see, I is here, J is here. Now see, I am declaring I equals to 0, comma K equals to 0 here. Now I am writing while I less than M. That means it travels till M minus 1. So I am writing condition while I less than M, this condition. Now I should copy all the elements present in A over the C. This is the first step. So what I should do? C of K, that is, now K is 0. C of K, that is C of 0 equals to A of I. That is A of 0. C of 0 equals to A of 0. So I am writing here. C of K equals to, wait, I will write here. C of K equals to A of I. Now I am copying the C of K equals to A of I. All the this 3 gets copied over here. After 3 gets copied, what it will do? Now K value increases here. Then I value gets increased here. Now you should copy this 5 over here. So you should increase I and K one by one after copying each elements. So you should write K plus plus here inside it and AI plus plus. So it copies 3 over here, then I and K gets incremented, then it copies 5 over here, then it gets incremented, then 10 it copies, then I and K value gets over here. Like this it copies all the elements. So now see. Now 10, 4, 6. 4, 6. Now K is over here and I is over here. Now it copied all the elements of this. This is the first step. Now second step is, now J equals to 0. Now I should compare. Now whether 12 is present here, no, then I should write 12. Then whether 4 is present here, no, then yeah, it's present. So I should not write here. Like that I should compare. So now see, I am writing the condition. For J equals to 0. J equals to 0. It starts from here. Comma J less than N. Comma J plus plus. This I am moving moving the J index from B from 0 to n minus 1. Now I am making another loop for moving this I from 0 to this m. So I is pointing here. Now see, for I equals to 0, comma I less than m, comma I plus plus. I have written another loop. Now see, now I should compare whether 12 is present here. No, 12 is not present. So you can copy 12 over here. So what I should write? I am writing the condition. If b of j, that is this, b of j is 12. So b of j is not equals to a of I. That means it's not present. I moves from 0 to m. So if it's not present over here, b of j not equals to a of I. If it is not present, then you can copy this b of j over c of k. So I am writing c of k equals to b of j. I copied over here. I copied the 12 over here. Now what you should do? Now this j gets over here. After copying this 12, j gets incremented and k value will also get incremented. K value is here now. So I am increasing k, I am writing k plus plus, j plus plus. I have written. So this is the condition if it's not present. Now if it's present, you should write the condition. So see, else if b of j equals to a of I. If it is equal, suppose see, now j is 4. Now you are comparing, this 4 is equals to 3 or not, it's not equal. Then I am moving here, I am at this position. Now 4 is here, equal or not, no. So I am moving I over here. Then 4 and 10 is compared, no, it's not equal. So now for j is, I is here. Now I am comparing whether 4 is equals to 4, yeah, it's equals to 4. Then what you should do? You should increase j, you should not copy. Now j is pointing here, you are not copying this j over here. So what it does, j is incremented. So I am writing j plus plus. This is the code for finding in unsorted. This is how you should find the union in unsorted arrays. Now let's find the time complexity. Now see. Now for this time complexity, let's find. Now time this. Now first there are two steps involved in this. First you should copy all the elements present in A in this C. So time taken is m because it travels in the size of array A, total elements present in A. So it took time m. This is first step. Then second step. Second step is you are at this position. J is at this here. Now you are comparing whether 12 is present in all elements in A. You are checking whether 12 is present in anywhere in A. So it took at this position it took m time. Then when this j is at here, you took again m time. Then while j is here, then you took again m time. So you are traveling this j from 0 to n. So in second step you took j moves from 0 to n. So I am writing n. Then in each index you are moving m time. You are comparing whether b is this element 12 is present in anywhere in A. So it took in each step it took m times. So m in second step I am n into m times. Now here m and n are equal. So I can write here n square. This is n square. And this m is I can write it is n. So total time taken is n plus n square. What is n plus n square? It is highest order is 2. So you can write O of n square. This is the time complexity for solving the union operation in unsorted array. Now let's see how to solve sorted array. Now see. Now I is at this position, j is at this position, k is at this position of C. Now see. Now first step is you should compare whether 3 is less than 2 or not. No, it's not less than 2. 2 is less than 3. That is b of j is less than a of I. So you should what you should do. Now 2 is less than 3. So you should copy 2 over here. You should copy 2 in the C array. Then what you should do? You should increase this k value. And you should increase this j value. because this is less. Now you should compare whether 3 is less than 4. Yeah, A of I is less than B of J. So you should copy this 3 over here. Now K gets incremented, then this I gets incremented because this is less. Now I gets incremented. Now you should compare whether 4 is less than 4 or 4 is great. A of I is less than B of J, or it's greater than B of J or equals to B of J. It's equals, 4 equals to 4. So what you should do? You should copy this. You should copy this A of I into this thing. So I am writing 4. Then you should increment this I value. Then you should increment J value. Then you should increment K value. This is how you write the union operation. Now let's write the code for this. See. Now at starting K is here, then J is here, I is here. Now I am writing I equals to 0, comma J equals to 0, comma K equals to 0. I initialize the value. Now see, while I less than M, comma J less than N, I have written this condition. Why I am writing this condition? Because I travels from all the elements present in A. Then J also travels all the elements present in B. So I am writing I less than M. It's still M minus 1. And this thing till N minus 1. So I am writing this. Now see, I should compare whether 3 is less than 2. That is A of I less than B of J. See, I am writing the condition. If A of I less than B of J. If this 3 is less than 2, what? Now see, not this case it's not possible. Now I'm marking here. Suppose see, J is here, I is here. Now you are comparing A of I less than B of J. Yeah, 3 is less than 4. So what you should do? You should copy this A of I over the C of K. So I'm writing C of K equals to A of I. I have copied this on this C array. So I am copying 3 over here. Now see, now what I should do? I should increase this K value over here. Then I should increase this I value over here. Because it's less than. So I am increasing K plus plus, I plus plus. Now see. Now suppose I is here, J is here. And K is also here. Suppose. Now see. I am comparing whether 3 is greater than this 2, whether A of I is greater than B of J. That condition I am writing. Else, if this A of I greater than B of J. If 3 is greater than 2, yeah, in this case 3 is greater than 2. So what you should do? You should, now see, 1 second. If your now J is over here, now 3 is great. Now you are comparing whether 3 is less than 4. No, it's greater than 4. So A of I is greater than B of J. So now see. Now suppose you are comparing whether 3 is less than 2. No, it's greater than 2. That means A of I is greater than B of J. So you should copy this B of J over the C of K. So you are copying this 2 over here. So what? C of K equals to B of J. You have copied. Now what you should do? You should increase this K value here and you should increase the J value over here. So I am writing K plus plus, J plus plus. Now suppose if I is here and J is here. Now I am comparing. Else, if A of I equals to B of J. Now see here, A of I, that is 4, is equals to this B of J. That it's equals to 4. Now what you should do? You should copy this 4 over here. This A of I you should copy to the C of K. So I am writing here. C of K equals to A of I. I copied it. Next what you should do? You should increase this I value. And next you should increase this J value. And you should increase this K value by 1. So I am writing here. See, in this bracket itself I am writing K plus plus. Then I plus plus. Then you are increasing j also. So I am writing here j plus plus. See, this is how you write the code for sorted array. Now, how to find union for sorted array? You have written the code. Now, let's see the time complexity. Now, see. Now, at starting k was here and j was here, I was here. Now, you travel this I from all the elements in this array m. So, time complexity came here m. Then in this also you traveled only once. Only once means you traveled from 0 to n minus 1 only once. So here you took n times. So what is the complexity? So m plus n. O of m plus n, because you took only once. I traveled from 0 to m minus 1, then j traveled from 0 to n minus 1 only once. Then O of m plus n. M plus n means it's having power 1 only. So I am writing O of m. O of n. So time complexity for this is order of n. This is how you should find the union operation in sorted arrays. Now I am going to teach you how to find intersection operation of two arrays A and B. Now we have two unsorted array and sorted array we have. Let's see how to find intersection operation. Now what is intersection operation? Intersection operation means you should find the common elements present in A and B and you should print it over the C array. This is what intersection means. Now let's see how it works in unsorted array. Now see. Now I is for traveling at A array from 0 to this I is index for traveling from 0 to m minus 1. The size of A is m. Now size of B is n. J is an index which is used to travel from 0 to n minus 1. Now let's see how it works. Now see, k is here, k is at this position 0. Now I is at 0. Now the A of I is 3. Now you should compare every elements in J. J travels from 0 to n minus 1. One by one you will compare whether 3 is present here, no. Whether 3 is present here, no. Whether 3 is present here, no. Like that one by one it checks. If it's not present, then I value increases by 1. Now I compare 5. Whether 5 is present in anywhere in this B. Yeah, 5 is present here. So if it is present, I will copy this 5 over this C of k. So it becomes C of k equals to A of I. Now let's write the code. How to write the code? Let's see. See, I am writing two loops. First I will write for I loop. For I equals to 0, comma I less than m, comma I plus plus. This I loop is used to travel in all the elements in array A. Now I am writing another loop for j equals to 0, comma j less than n, comma j plus plus. This is used to travel all the elements in B. Now I am comparing. Now if I am writing the condition, see, suppose 3 I am comparing whether 3 is equals to 12, no. Whether 3 is equals to 4, no. Whether 3 equals to 7, no. Suppose if here 3 is there, if A of I equals to A of j, suppose here I is at this position, suppose I is at this position. Now you are checking one by one in j. If A of I equals to B of j, here j is at this position. Now both are equal. Now what you should write? I am writing the condition. If A of I equals to B of j. If this is the condition, you should print that 5 over this C of k. You should copy it. So what you should do? C of k equals to A of I. Now what you should do? After copying this 5 gets copied over here. 5 gets copied over in the C array. Now you should increase k by 1. You should increase the k index. Now you should increase the I index also. So I am writing k plus plus I plus plus. Now see. Now if it is not equal, suppose in this condition I is here and j is here. Now it's not equal. 3 is not present here. So I am writing the condition. Else if A of I not equals to B of j. If it is not equal, 3 is not present here. So what you should do? you should move I to next position. So I'm writing I plus plus. This is the condition, this is the program which you should write for finding an unsorted array. Find the intersection in unsorted array. Now see, now let's find the time complexity. Now time complexity is, suppose see, now I is at this position and j is at this position. Now you are fixing 3. Now you are comparing 3 in all over this thing. And next you are at a of I is 5. Then you are comparing whether 5 is present anywhere in this element b. So one loop, that is I loop, will travel from this all the elements in array a. So I am taking m because it travels all the elements in this array a. Now in each travel it checks whether any element is present in the array b. So in each one it takes n times. So I am writing m into n because m travel is there in array A. In each travel, n travel is there in array B. So m into n. Now m and n are same. So I can write n square. So the time complexity is O of n square. This is time complexity is more. Now see. Now let's see how to find the intersection in sorted array. Now see. Now I is here and j is here. Now you should check whether a of I is less than b of j. You should check. Now see, 3 is greater than 2. It's not equals to 2 or it's not less than 2. It's greater than 2. So what you should do? You should increase I. You should increase I. Then you should compare. Now whether 2 is equals to 4 or 4 is less than 2 or 4 is greater than 2. Now it's not equals. 4 is greater than 2. So you should move j to this position. Now see, you should compare whether a of I is less than b of j or a of I is equals to b of j, like that. Now it's equal. If it's equal, you should copy this a of I into the c of k. So you are copying 4 over here. Then after copying, k value was here right at starting. Now k value gets over here. K value increments and I value and j value also increments. J is here, I is here now. This is the condition. Now like that you will go on. Now let's write the code for it. Now see, I equals to 0, comma j equals to 0, comma k equals to 0. At starting I is here, j is here, k is here. Now I am writing the condition. While I less than m, comma j less than n, I am writing this two condition. I less than m and j less than n, because I can travel from 0 to m minus 1 because size of array A is m and size of array B is n. So j travels from 0 to n minus 1. So I am writing this condition. Now see, now you should check if a of I is less than b of j. That means whether 3 is less than 2. So I am writing the condition. If a of I less than b of j. Now what you should do? Now you check whether 3 is less than 2. No. Suppose if 3 is less than 2, suppose see, if j is here, suppose this condition, suppose I am making. Now 3 is less than 4. A of I is less than b of j. So what you should do? You should move this I towards here. You should not copy this 3 over here. You should not copy because they are different. Now you should move the I value. So I value increases by 1. So I am writing I plus plus. Now the other condition, else if a of I greater than b of j. Suppose see, now I is at 0 and j is at 0. Now see, you are comparing whether 3 is less than 2 or 3 is greater than 2. Now this 3 is greater than 2, that means a of I is greater than b of j. Now it follows this condition. If it is greater means this is small, b of j is small. So what you should do? You should increase j value by 1. So now j plus plus. I am writing j plus plus. This is the rule. Then suppose see, now I value is in this case and j value is in this case. Now 4 equals to 4. So a of I equals to b of j. So I am writing the condition. else if A of I equals to B of j. Now 4 is equals to 4. Then what you should write? This is intersection. This is common elements in A and B. So you should copy this A of I in C of k. You should copy. So I'm writing C of k equals to A of I. Now I copied. Now this 4 gets copied over this k value. Now what you should do? Now you should increase I value by 1, index I by 1, and j also you should increase by 1. Then k also you should increase by 1. So now see, I am writing k plus plus because you increase k, then I also increase, so I plus plus. Then j also you increase, so I am writing down j plus plus. This is how the code. This is how to write. How you should write the code for sorted array. This rule is applicable only for sorted array. You can't use this condition like merging. This you can learn in merge sort. Like this only we use how to find merging. So this cannot be applied in unsorted. Only sorted we can apply. Now let's see the time complexity. Now see time complexity. Now for traveling in I, suppose I was here and J was here. How much time you took for traveling A? A took only once, that is M time. That is it traveled to I equals to 0 to M minus 1. It took only one time to travel whole array. So I am writing here M. Then in this J also took only one time from 0 to N minus 1. So I am writing N. Now M plus N, because it took this A took M times and B took N times to travel. So M plus N. M and N are equal in this case. So I am writing 2N. Now what is 2N? Highest order is 1. So O of N. This is the time complexity, order of N. This time is lesser than this time. O of N is less than O of N square. So you can say this is faster. Now that's all for this. That's all for today, and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.